Recall that a function is a procedure that assigns one output, exactly one output for each valid input. We try to reverse the procedures. However, it might not exist. This is what I mean. And the function f of x equal to 2x is easy to reverse. If I tell you the output is y equal to 6, then I can solve for x. The x must be 3. In fact, for any number y, if I know f of x equal to y, and x has to be y divided by 2. The point over here, the x, there's only one answer. So this procedure of solving for x produce one answer is a function, and that function we call f inverse of x or f inverse of y in this case, using the letter y. But if I look at the function x squared, I tell you the y output is 9. Now there are two possible answers for x, and this association is not a function. Therefore, f of x equal to x squared does not have inverse functions. And here's the pair of inverse function 2x and y divided by 2. And I can represent this cycle using these pictures. And so it given of x, and it will be multiplied by twice and become the number y. And to go back to the x, I divided y by 2. So they go in cycle. So I can write that in compositions of functions in this manner. X go to f, and then go to f inverse. Then it go back to x, and the other way around too. And on the pictures in the graphs, and here's y to f of x. If I know what y's are, then there's only one x for each point y. That's each y that's given. Okay, associated only to one x. But if I look at the graph of y to x squared, that's not the case. If I tell you y is 9, there are two possible numbers associated with 9, so that's not a function. So therefore, x squared doesn't have an inverse functions. And when do we have inverse function? What the requirement is therefore is for any two numbers that are not the same, they must produce two outputs that's not the same. These type of functions we call one-to-one. One-to-one function are exactly the type of function we can produce is inverse of also functions. Y equal to x squared is now 1-to-1 because got two number goes into 9. So I can now reverse as a function. So the inverse doesn't exist. And how do we solve for the inverse? We basically just solve for x in terms of y and to do a little algebra for this. Now we get x equal to y for y plus 20/3. Now, and to verify the identity, I'm going to use x as a variable so we can check easily the algebra, plug in the functions, find out that's x, and do the other way around, we get x back. In general, this is not easy to do. Okay, so this is how we solve for inverse function. Bye-bye.